Polar and rectangular representations of a sine wave are used to simplify the basic mathematical procedures that are often too difficult to carry out using the sine wave's graphical representation. A times sine omega t plus or minus theta is the general form of a sine wave and is used to represent it graphically. The general form provides the values of important variables. A is the amplitude of the wave and informs us of the distance from the horizontal axis to the maximum value of the function in the vertical axis. In surf terms, this would be the max height the wave gets before it begins to break. The period, represented by omega, describes the span in which the function progresses before repeating the same path. Here, each wave would be one period. The plus or minus theta represents the phase shift. The phase shift is the displacement across the horizontal axis. If theta is positive, the function is shifted left on the graph. If theta is negative, the function is shifted right. Phase shift can be thought of as low tide and high tide. Representation of sine waves using complex numbers can be done by converting from general form to polar form, then from polar to rectangular. The polar representation of a sine wave is r angle theta, where r is the magnitude and theta is the direction. To obtain r from the wave's general form, divide the value of a by the square root of 2 to get the RMS value. The phase shift value is equal in general and polar form, meaning the angles in both equations are the same. The rectangular representation of a sine wave is z equals a plus jb, where a and b are real numbers and j is the imaginary number square root of -1. To convert polar to rectangular form, you need to find the real and imaginary parts of the equation. A is found by calculating the product of r and cos theta, and b is the product of r and sine theta. To return the rectangular form of a sine wave back to its polar form, find r by taking the square root of the sum of a and b squared, then find the direction of phase angle from the inverse tan of b over a. The polar representation of a sine wave eases the process of multiplication and division. To multiply two sine waves, take their polar forms, multiply their respective magnitudes, and sum their phase angles. To divide the magnitudes of both polar equations and subtract the denominator phase angle from that of the numerator. The rectangular form of a sine wave simplifies the addition and subtraction procedure. To add multiple sine waves, take their rectangular forms and find the sum of all the real numbers and the sum of all the imaginary numbers. To subtract one sine wave from another, to subtract one real number from the other, then do the same for the imaginary parts of the equations respectively.